Hello everyone, welcome to KTS Unboxing. Let me show you how you can use this particular repository or code to create Kubernetes cluster with multiple runtime. Just made one release 1.2, which enable you to create a Kubernetes cluster with multiple runtime. Those runtime are runc, the most known uh, low level runtime for container. Then crun, basically it's a C versions of the runc. There is not much difference in functionality though. Kata, basically it use upstream versions of the QEMU virtualizer, and it create hardware virtualizations for container. And gvisor, basically it narrow down the access to kernel feature for much more secure way to create container. Now the detail around all these particular runtime, the plan is to have a more detailed blog or video blog around it, which will take considerable amount of time. But with this release, as we can use multiple runtime in multiple node, same Kubernetes cluster, multiple node with multiple version, I thought to prepare a small tutorial where I can show you how you can use this particular code, how you can create a cluster with multiple runtime, and how you can change these configurations you uh, the way it's supposed to be used. So the link, I'll give the link at the bottom of this YouTube video, as well as the package is available here. Sorry, the release is available here. This release is the tag is multiple runtime, and release version is 1.2.1. It's a pre-release, and it's clearly only support libvirt. I didn't get time to test it with virtualbox. Um, runc support, as I said, it support runc, crun, kata, and gvisor. CNI is default. Default means basically it is a manual routing from no, pod to node to pod. Basically, calico and cilium is not tested but will work. But it's not tested, and it can give unpredicted result. Kubernetes version 1.25, the most latest one. These are other versions here. CRI tool runs version, crun version. Please note kata and gvisor random version has no effect. So this is basically a small summary of things this particular release support, and only this particular release will give you support for multiple runtime. Please to remember. So let me, and this configuration documentations has a lot of information uh, which is useful. Uh, this particular table talks about different command you can use on top of setup.sh. Basically, there is no delete function or delete keyword for the worker nodes. Del basically means the complete destruction of the cluster, but scale basically scale up or scale down the worker node. I'll show you in a minute. Um, Now regarding kata and gvisor, both of this runtime uh, since 8th or 9th of November went through major changes. So documentation is a bit unpredicted. It's a lot of hacks and a lot of workaround. Like for gvisor, gvisor do not support C group version 2. So the worker node uh, where we are using gvisor, that needs to switch back to C group 1. For kata, um, basically the snap version of the kata runtime has the proper configuration, not the source code which I'm compiling. So this is something, some major workaround has gone through, and it's not ideal that we are building the runtime in the node itself. Like for runc or crun, the code itself will separately download the source code, compile it, build it based on the version you mention in the config file, and then it actually copy those binaries to a particular specific worker node, and that's the way it should work. But for kata and gvisor, the complete concern or dependencies of all these activities happening in the node itself. Definitely it's a test bench, so I can afford to do these non-ideal things, but this is because kata and gvisor, none of them has a proper documentation the way it should work. This should not be that hard, but this is the way it is. I'll not go through the code, maybe that is part for a different time altogether, but let me show you how this code can be used. So let me first destroy the existing clusters I have. While it's happening, let me go through this configuration file. So basically this particular kts config.yaml give you lots of option where, like provider, you can switch to virtualbox, but for this particular release it is only libvirt, means kvm. Domain, you can have your own domain. Here it is kts.local. IP start, IP end, this is self-explanatory. Number of node for the control panel. So basically you can update this control panel node number to anything you want, but it will internally create one load balancer VM and will load balance the control panel node. Worker node or worker node, CNI default, but you have multiple options to configure, which are, as I explained, mm, calico and cilium. But for the time being, let's keep it default. I'll explain what default means later. Version is basically kts version. This kts will be prefixed with any of these placeholder values. Then containerd version, CNI plugin version, build directory. You have to provide a path. In this path, all this source code other than etcd, all the source code, Kubernetes, containerd, CRI, CNI plugin, runc, as well as crun, basically will be downloaded. So if I go to make.sh, it will list out what are the, build, it will show you the list of things. It's download. It's download Kubernetes source code, it download CRI tool, it download containerd source code, it download the plugins, container networking plugins, it download crun, it's download runc. But for kata and gvisor, I'm not uh, downloading the source code or building from source code. For kata, I'm building the runtime for source code, but for gvisor it is completely only the packaged runtime. So once you download and switch to either release underscore 1.2 or gvisor, but I prefer you guys use release 1.2, then you can do, once you set up the path for the build directory, uh, let's do this. Let's change, I let's keep it 1. Basically I'm not load balancing the control panel at this moment, just to reduce the time. and then let's just do this one. And for the first node, I want that node to use runc and runc version 1.1. So with this one, and this private key name basically is the SSH key name, which is going to be configured for the node so that you can SSH into those nodes. Now in case of Vagrant SSH do the work, but that's the options, that's the way it's been configured. um, so the first thing, once you have this all this configured based on your configuration, or based on your home lab setup, the first thing you do is do make. This make basically will ensure that all the source code is actually downloaded, right? Now for me, basically what it will do, it will create the temp folder, and then it will download, the make actually create the build directory. It will look for the build directory and download source code for all these Kubernetes and Kubernetes related components, right? And then, so yes, so for me, it's already there in this path. That's what it's showing, that Kubernetes build directory exists, Kubernetes Kubernetes repo exists, CRI tool repo exists, containerd exists, runc repo exists. So it will not do anything. And if I do build, it will try to build and copy the binaries to a temp folder inside your workspace. Now for me, basically building a Kubernetes source or containerd takes some time. Specifically, Kubernetes takes time, and I do switch back to different Kubernetes version time to time. So this temp folder, once you build it for the first time, under your temp folder, it will create a folder or directory with the versions you mentioned in this config file, and retain or keep the binaries for you. So next time you do not need to build from the scratch, but for the first time it will take some time. So if you do build, for me it will show that Kubernetes binaries already exist for version 1.25, which I have mentioned here, and for the rest of it, it will follow the same. Now with this, it means what I'm telling my setup is that, hey, create a control plane with one node, and create one worker node with runtime runc, right? It's pretty normal. Now internally it will create a load balancer also. So if I just do, I can create separate, I can create the control panel separately. If I just do this dot setup.sh cp, means control panel, it will only create the control panel. But for the time being, I'll just do setup.sh all, which will create control panel. And once control panel is established or created, it will scale up to one worker node with the specific runtime runc with runtime version 1.1. So if I just do this, so it will spit up a lot of details. This is basically a test page, and I do a lot of changes to the source code and see like what are the effects. So this basically help you to debug very quickly, as well as it will emit a lot of information which is kind of has educational purpose also. It creates all the certificates. In one specific video, I may go through the code line by line. That's the objective, that how basically under the hood all the source code come together and work to create a Kubernetes cluster, right? Which Kube ADM or any managed distributions don't give you that insight, and that's the main purpose of this particular effort. In a moment, control plane will finish up configuration, and then it will try to scale to one worker node with runc. Yes, now it's scaling up to one worker node. Basically, all the artifacts gets generated under the temp folder. And if you want to check what is getting installed, these are the files which is getting generated dynamically based on your setup under temp folder. Like control plane script, this is going to run under each of inside each of the control plane node. HCD configuration of HCD, which gonna run under or inside each of the control plane node. The HA proxy for the load balancer VM, where I'm using HA proxy to load balance Kube API server. Then configure worker sh basically is based on the runtime and the CNI of your choice. Like in this case default, it will actually produce the script which needs to run to set up kubelet, kube proxy runtime for each of the worker nodes, right? And then it will also try to rewrite the host. It also create the routing. Now in this case, one single worker node, so routing has nothing inside. And the first thing it will create is the libvirt vagrant XML for the network, where all these worker node will sit, or the control panel node is getting provision. So now only one node created, and this node also, for the first time when you are creating it, it will also install core DNS, right? So there are a couple of things to remember. Once you have one worker node and you scale up or scale down, until unless you are scaling down to 0, changing CNI to anything else like cilium or uh, calico won't take any effect. To change CNI to anything else other than what you have just configured, you have to scale down to 0, and then you have to start again. That is one of the conditions here. It will it won't let you, means it will let you change here, but it won't take any effect. Now I have one node with runc. What I'll do, I'll change it to, I can change it to crun, but crun basically the C versions of the runc much more faster, and it will just replace the binary. That's it. It has no other special effect like kata or gvisor, right? I'll explain kata and gvisor later. In fact, the documentation and readme has all the detail. If you go to kata, if you go to gvisor, you can understand what exactly these two runtime does. And I have planned to have a few more sessions on these two runtimes and how it will shape the future of multi-tenant class chat, trusted, untrusted workload, right? Uh, it's very interesting. Anyway, now let's switch to kata. Now, for kata, as I said, the kata runtime getting built from the latest release inside the node itself. So basically this runtime will have no effect. This runtime has effect only for crun or runc. So I'm not going to change anything. I'll just change the runtime to kata. And then I'll change or increase the number of worker node to 2. So now basically if I go back to my setup.sh, rather all, if I do scale, this will understand that right now we only have one node at present. Desired state is 2 node, so it will try to scale up, scaling up. Now all this is possible, which is again should be a different topic altogether. This is all possible because to start understanding Kubernetes, you have to understand what is that particular component which is not redundant, and that is OCI or Open Container Initiative standard. Now OCI set the standard for runtime. If we go to a specific, uh, if you go to the OCI specification, uh, OCI image specification, OCI container specification, so you'd see now there is no difference between process separations and hardware virtualization or hardware abstractions, right? So basically, back in 2019, there was a debate that where we'll draw the line, which is what is container. It used to be since beginning of Docker or since beginning of the container understanding, it used to be the process isolations. But now OCI standard also support um, hypervisor, hardware abstractions, right? Now, Kata is actually a great example of it. It takes that OCI specification, but the interpretation of OCI specification is a completely different in case of Kata. Now, gvisor is not a hardware abstractions or it's not using any sorts of hypervisor. It is actually narrowing down the access to the kernel module or feature more securely, so that no one can manipulate or get access to prime kernel feature from a container itself. Basically it is rationing the access to the Linux kernels. So this is the two different type of low level runtime working in tandem in one Kubernetes cluster based on the based on containerd runtime interface. It is only possible because containerd respect OCI, and all these runtime runc, crun, kata, gvisor also do respect OCI. So these standards same across the board. That's why all of these runtime work if properly configured with containerd, and containerd has no issue to make this particular runtime work. So for containerd, it's all about container creation of container based on the standard, but the interpretations of the same varies between this low level runtime. I'll have much more dialogue, much more proof inside based on the code, walkthrough of the code of OCI standard, and I'll try to show where exactly those OCI standards gets implemented with runc and crun. Kata and gvisor is bit tough to walk through right away, because it is uh, still, I believe, in their early stages. There are some implementations, but for me it's not ready at all. But anyway, now this is something we created with kata. So let's see, k node. So now this one newly created, so it has kata runtime. Now for an example that yes, I can run, if I go to the temp folder and if I open configure worker sh, I will see like it's only configuring the container D respect to kata runtime. There is no runc. There is no runc, right? Now to test everything is working for kata, first of all we can go through this particular informations where I build the kata runtime in the node itself, and then kata runtime check showing that system is capable of running kata container, right? So the code which does that, that is basically, first of all you have to check if your node uh, is actually able to do these sorts of virtualization. These two line of code do uh, uh, inform you that, and then this kata runtime check will show that yes, there is no issue, system is capable of running kata containers, right? So always check under temp folder which has the source code. So basically this script will generate this file based on the configurations you do. So now to test kata container is working, I have a sample. Now this sample, for the time being, to keep things easy and simple, uh, uh, though I'm using runtime class, uh, I'll actually select a particular node. In this case, this node is basically 1281. This is the node where kata runtime got installed, just newly created, right? So I'll just check this, change this to 1281, and let's see. Okay. Okay. So this busybox runtime now basically using runtime class kata container, and it is basically uh, not a process isolation. It's basically a lightweight VM, but that's a very generic term. I'll have much more detailed dialogue around it. Now I have a Kubernetes cluster which has two nodes, one running with runc, one running with kata. Now if I go back to the routing, I would see that this routing automatically created for each of the nodes separately. It's basically routing the pod IP range through the node gateway, right? So this will also get generated automatically. Now if I just go to configuration file, make it 3, basically increasing by one node, and just change it to gvisor. And as I said, for gvisor and kata, this runtime version basically has no effect. And I'll do one more scale. It will scale up and try to create the node with gvisor. So now you have a cluster, if it all goes well, you have a cluster where 3 different low-level runtime running and letting you create a pod specific for specific use cases. So basically you can extend this concept through a node pool, where one node pool for trusted workload where you need hardware level abstractions, right? One specific node pool where you or node where you need a narrow access to the Linux kernel, and you can run everything else on a node pool where runc is running, maybe that is not suitable for multi-tenant application because it's not secure. It's not that secure, right? So now the line between the container, process isolations, hardware abstractions, these are all gone. Uh, there is no demarcation, there is no separation. Uh, Basically, OCI is a big normalizer. To start understanding Kubernetes, one should start with OCI. OCI is the one thing which is not replaceable in this equation. Container D can be replaced. In fact, at one point of time, Kubernetes itself can be replaced, but the standards needs to be one single standard. It has its own disadvantages. We can discuss that later. So as I said, basically for this one, configure, basically trying to switch back to um, say group 1 and updating graph. That's why this node needs to be rebooted. So I'll wait for a few seconds and then I'll try to check if it is created. So the most latest one is actually having gvisor, right? Now that's there. And to check this one, I also have one gvisor container example. Basically same thing. I'm using runtime-class. This is a great example how Kubernetes is changing based on industry demand, right? Anyway, uh, this I would like to run in a node where it is running gvisor. So it should be 1557. This is 33 seconds, so this is the latest one, win 1557. So gvisor is not that stable. I hope it runs. Okay, good. So now I have one cluster with three nodes, three different low-level runtime, and now you know how you can do that. Now, as I said, like if you want to scale it down, you can just reduce the number. Now, at this point of time, the logic of removing a node is not a functional logic. It just checks the index of a node. Basically, it checks this index which I am generating a 4-digit index number, and whatever is bigger, it removes that. Now, why? Still, I have the scope where I can implement any logic, right? It can be like if you want to remove a node based on a specific configuration, you want to remove a node based on the dynamic load it has, or the age of the node, or whatever the functional way a node needs to be removed. But that's not the true objective uh, of the bench right now. Slowly those logics will be implemented, but for the time being, if you see, if you want to remove one by one, it will only pick up the node with the higher index. And if you want to just scale down to 0 just to change the CNI, you can just do this 0, and if you do scale, it will basically scale down, remove all the worker node, and then you can make change to CNI, and again you can start rebuilding your worker plane. Thank you.